Hello viewers, welcome to my channel. I am Hashim. So far 9 problems I have completed on normal distribution. After doing 9 problems, I think my viewers got a good comment on this topic of normal distribution. And this is the last video where 2 more problems I am going to explain, 10th and 11th. Still 3 more problems are there, 12, 13, 14. These 3 problems I am giving you for your practice. After doing 11 problems, you will definitely be in a position to attempt the problem. So these last 3 problems, practice yourself. Remember, if only listening the lecture or watching the video is not sufficient. You have to practice yourself. And watch all the videos from beginning till and don't skip in between. And before that, you must watch the theory video. Without understanding the theory, you should not do the problem. Now, before starting the 10th problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Take the screenshot of the points written on the board, then I'll explain. Come on, see the 10th problem. The results of an examination are given below in a summary form. Result: passed with the distinction 10% of candidates, passed 60% of candidates, failed 30% of candidates. That means all the candidates are classified into 3 categories: distinction and only passed and failed. Right? And percentage are given 10%, 60%, 30%, 100% students. It is known that candidates get plugged if he obtains less than 40 marks out of 100. Plugged means failed. That means the minimum marks is 40 for passing. If a student gets less than 40 marks, he will fail. So how many students have failed? 30% of students have failed. That means 30% of the students got less than 40 marks. That's why they have failed. While he must obtain at least 75 marks in order to pass with distinction. That means 75 or more, they will be put in distinction. So how many percentage of students got distinction? 10%. 10% of students got 75 and more. Whereas less than 40, how many students got? 30%. By using this data, determine the mean and standard deviation of the distribution of marks, assuming this to be normal. So actually in this problem, we have to calculate the mean and standard deviation. But the problem is little bit twisted. And this is also one of the examination problem I have taken from the question paper. Problem is simple. The only understanding the contents of the problem is little bit twisted. That means some percentage is given failed, some percentage is given distinction. So how much percentage? That we will discuss. First of all, let X denote the marks of the students, which is given as normally distributed with mean mu and standard deviation sigma. Mu and sigma we have to find out. Right? This sentence always you should write in examination. Now, by drawing the normal curve, we can understand the context. So, how much percentage of students got less than 40 marks who failed? 30%. It is given 30% of students failed. When failed? When they get the marks below 40. So, in this curve, this is 40 marks. X is equal to 40. And below 40 is this shaded area. So, how much percentage? 30%. 30% means 0.3. The total area from left side area is 0.5, right side area is 0.5. So 0.5 minus 0.3 is 0.2. So in this shaded area is 0.3, unshaded area is 0.2. Over. Now how much percentage of students got distinction? 10%. 10% got distinction. And what is the passing marks for distinction? 75 or more. So here right side X is equal to 75. So how many students got? 10%. So this area is more than 75. and 10%. 10% means 0.10. So unshaded area 0.5 minus 0.1 is 0.4. So here 40%, here 20% is the unshaded area. By using this area, we can find out Z value. Right? By using this area. What is this unshaded area? 0.2. So what is the value of Z for an area of 0.2? I told you this area table. You can get in any textbook, and also in the description I have given a PDF. Take a printout, keep it ready. Even in examination you can carry. Now 0.20. So in this first column is Z value, first row is Z value. In between, in this body of the table, all areas are given. So area 0.2. So 0.2 you search, where is 0.2? Yeah, 0.2, 0.2019 and 0.1985. See the nearest of 0.20. One value is 0.2019, the other value is 0.1985. So it appears that 0.1985 is nearer to 0.2, right? So it is in 0.5 under 2. 0.5 under 2, so 0.52. So from Z, value of Z for an area of 0.2 is 0.5. Just now we have seen. Similarly 0.4. Now search in the area table 0.40. Where is 0.40? Here. 0.3997 and 0.4015. 0.4015 is little bit far away, whereas 0.3997, this is very near to 0.4. So this 0.3997 is in the row 1.2 in the column 8. 1.2 under 8, so 1.28. So we can see here for Z is equal to 1.28. The value of Z for an area of 0.4 is 1.28. So for this X is equal to 40, Z is equal to minus 0. Left hand side, that's why I am writing minus. Here X is equal to 75, Z is 1.28. Now, we can substitute these values in the standard normal variate formula. The standard normal variate is Z is equal to X minus mu divided by sigma. X minus mu divided by sigma. Now we substitute. Z is equal to minus 0.52 is equal to X. X is 40. So 40 minus mu divided by sigma. We don't have mu. We don't have sigma. Now cross multiply. If we make a cross multiply like this, then what will happen? Minus 0.52 sigma. So minus 0.52 sigma is equal to 40 minus mu. Bring this mu to left hand side. So minus mu will become plus mu. So mu minus 0.52 sigma is equal to 40. This is equation number 1. First equation. Now we'll come to the second equation. This. Z is equal to 1.28. So 1.28 is equal to 75. X. 75 minus mu by sigma. Again we'll make a cross multiplication like this. So what will happen? 1.28 into sigma is 1.28 sigma is equal to 75 minus mu. Take this mu to LHS. So minus mu will become plus mu. Mu plus 1.28 sigma is equal to 75. This is equation number 2. Two equations we have. Solving these two equations, we can get the value of mu and sigma. Right? The first equation, mu minus 0.52 sigma is equal to 40. Second, mu plus 1.28 sigma is equal to 75. Change the signs. This plus will become minus, plus will become minus, plus will become minus. So plus sigma, plus mu minus mu will get cancelled. So minus 0.52 sigma and minus 1.28 sigma. Here also minus, here also minus. So now both add up. 0.52 plus 1.28, 1.80 sigma. So minus 1.80 sigma is equal to 40 minus 75, minus 35. Now minus is there on the LHS, minus is there on the RHS, cancelled. So sigma is equal to 35 by 1.8. You will get 19.44. What is this 19.44? Sigma, standard deviation. Now substitute the value of standard deviation in any one of the equation, either first or second, any one. I am substituting the first equation. We'll get the value of mu. So mu minus 0.52 sigma is equal to 40. Now in place of sigma, I am substituting 19.44. So mu minus 0.52 into 19.44, you will get 10.11. Now take this 10.11 to RHS. So minus will become plus. So 40 plus 10.11, 50.11. What is this? Mu, mean. So mean we got 50.11 and standard deviation we got 19.44. That's all. So after listening, after watching, definitely it looks very simple, right? Now, 11th problem, see carefully. The average daily sales of 5,000 branch officials was 1,50,000 and the standard deviation was 18,000. Here, the random variable x denote sales, which are given as normal distribution with a mean of 1,50,000 and standard deviation 40,000 for 18,000. Indicate how many branches have sales between 1,20,000 and 1,45,000. Different three questions are there, A, B, C. One by one we will attempt. Let x denote the average. Just now I told you z is equal to x minus mu by sigma, x minus 1,50,000 by 18,000. Right? Now first question, number of branches having sales between 1,20,000 and 1,45,000. Right? So when x is equal to 1,20,000, what is the value of z? 1,20,000 minus 1,50,000 divided by 18,000, minus 1.67. This is the value of z when x is equal to 1,20,000. Similarly, when x is equal to 1,45,000, so 1,45,000 minus 1,50,000 divided by 18,000, minus 0.28. Both we are getting minus because both are less than 1,50,000. The average sales is 1,50,000 and both the values are less than 1,50,000. That's why we are getting on the left side, minus. So here in this normal area curve, center mu is equal to 1,50,000, z is equal to 0. Now 1,20,000, x is equal to 1,20,000 and z value is minus 1.67. When x is equal to 1,45,000, z is equal to minus 0.28. Now we need this shaded area from 120 to 145. So first of all we calculate what is the area from z is equal to 0 to z is equal to 1.67. So what we get is completely this area we get. From this to this. Complete area we will get from 0 to 1.67. So if you refer the area table, area table 1.6 under 7. So here 1.6 under 7, you will get 0.4525. So here 0.4525. But we don't require the complete area. We require only shaded area. So this area we subtract. This area we subtract. So what is the area from z is equal to 0 to z is equal to 0.28? So 0.2 under 8. Refer the table 0.2 under 8. It is 1103. So this area is 0.1103. Here it is given. The area from z is equal to 0 to z is equal to 0.28 is 1103. So from the total area 0.4525, we subtract 0.1103. So we will get the area of this shaded region. That's what we want, right? So here the area from x is equal to 120,000 to x is equal to 145,000 is 0.4525 minus 0.1103. You will get 0.3422. So this shaded area is 0.3422, or we can say 34.22% of branches have sales between 1,20,000 and 1,45,000. 34.22. But it is asking you how many branches. The total number of branches are how much? Given in the problem in the first line, 5,000 branches. So out of 5,000 branches, how many branches are expected to have the sales between 120,000 to 145,000? Right? So here 5000 into 0.3422, you will get 1711. So 1711 branches are having the sales between 120,000 to 145,000. That's it. A bit completed. Now what is the B bit? B bit between 140,000 to 165,000. Between 1,40,000 to 1,65,000. 1,40,000 is below the average and 165,000 is above the average. So here between 140,000 and 165,000. When x is equal to 1,40,000, so z is equal to 140,000 minus 150,000 by 18,000 minus 0.56. Similarly, when x is equal to 1,65,000, so 165 minus 150 by 18, 0.83 positive. Now we'll draw the normal curve. Center mu is equal to 1,50,000. Left hand side 140,000, right hand side 165,000. For 140,000 minus 0.56. For 165,000 0.83. Now we have to refer the table. For an area of area for z is equal to 0 to z is equal to 0.56. In the row 0.5, in the column 6, you will get 0.2123. So this area is 0.2123. Similarly, we want the area from z is equal to 0 to z is equal to 0.83. 0.8 under 3, you will get 0.2967. That's it. We want the complete shaded area from x is equal to 140,000 to x is equal to 165,000. Add up both these. 0.2123 plus 0.2967, 0.509. 0.509. If you multiply by 100, you get 50.9%. So 50.9% of branches are expected to have the sales between 140,000 and 165,000. If you want the number of branches, multiply with 5,000. Total number of branches are 5,000. So 5,000 into 0.509, you will get 2,545 branches. Out of 5,000 branches, 2,545 branches are expected to have the sales between 140,000 and 165,000. That's it. Last, C bit. More than 165,000. So how many branches are expected to have the sales of more than 165,000? When x is equal to 165,000, what is the value of z? So 165,000 minus 150,000 divided by 18,000. Here it is not 1800, it is 18,000 is equal to 0.83, right? So here 165,000 is more than average, more than 1,50,000, so right hand side. But we need more than 1,65,000, so this is the shaded area we require, right? So area from z is equal to 0 to z is equal to 0.83. If you refer the table 0.8 under 3, you will get 0.2967. So this unshaded area is 0.2967. But we don't require unshaded, we need the shaded area. So total area on the right hand side 0.5. So 0.5 minus 0.2967 is 0.2033. So the area for x is greater than 1,65,000. X is greater than 1,65,000 is 0.5 minus 0.2967, 0.2033. Or in percentage terms, 20.33% of branches are having the sales more than 1,65,000. The number of branches, if you want, 5,000 into 0.2033, 1,016.5. In other words, 1,017 branches are expected to have a sales of more than 1,65,000. That's all. This is the end of problem number 11. So far I have completed 11 problems. Remaining 3 problems I am giving you for your practice. Don't neglect, don't ignore. Try to do those 3 problems. So inshallah, in the next video, I will start the next topic called chi-square test. That is also one of the important tests in statistics for management. So if you are satisfied, give a like to the video, share my channel, and don't forget to subscribe my channel. So inshallah, we'll start the next topic in the next video.